Okay, today you guys are going to learn about pyramids. So what you see at the beginning of the notes are two square pyramids. We name our pyramids based on what their bases are. Okay, so in this case they're squares on the bottom, so we call it a square pyramid. So that's the base in yellow there. The sides we call lateral faces, just like in a prism. Where the lateral faces are meeting are also lateral edges, just like in a prism. And where the lateral faces meet the base, those are our base edges, just like they were called in the prism. One feature that a pyramid has that a prism does not have is this apex, which is where all of the lateral faces meet. To find the actual height, which could also be called the altitude of the pyramid, it is measured straight down through the center of the pyramid to meet the base, forming a right angle, perpendicular distance. Okay. The slant height is if we take one of the lateral faces, which are going to be triangles, it is the height of one of those triangles. So it is actually outside on the surface of the pyramid. So here you guys see the difference between a regular pyramid and a not regular pyramid. We can still have not regular pyramids, but all the formulas you guys are going to learn today only apply to regular pyramids. Okay? And here are some important qualities of a regular pyramid. All the lateral edges are congruent, all lateral faces are congruent, and the altitude, the height when we draw it in, meets the base right at its center. Okay, we're going to use that as we work through our example today. You'll see that that's important. Okay, our theorem 12.3 gives us a way of finding lateral areas of pyramids without having to find each lateral faces area and adding them together. We can just do 1/2 the perimeter of the base times L, where L stands for the slant height. Okay? So we're going to use that formula. This note is important because it says if a pyramid is not regular, you would need to find its lateral area by finding the area of each lateral face and then adding those together. So just like yesterday, lateral area is the area of the sides of the shape. Okay? Then, similar to yesterday, to find your total area, you take that lateral area, but this time we only add on one base, not two bases, because a pyramid only has one base. So we have the sides covered by the lateral area, and then to get the total area, we just add that base there on the bottom. Okay, the volume of a pyramid is going to equal 1/3 the base area times the height of the pyramid. Okay, so those are our three important formulas that we're going to use to find these different lateral area, total area, volume. Okay, let's work through this example together. So before I can find lateral area, total area, or volume, I am always going to need to know L, the slant height, and H, the regular height. So given this diagram, let me show you guys how you would find that. Okay, it tells me it is a regular pyramid. That means that the base is a regular polygon. So if it's a regular quadrilateral, that means it must be a square. Okay, so if that side's 6, guess what? This whole side is 6. When we draw in that height, this is going to be an isosceles triangle here. So I could have that marked perpendicular, and it's going to bisect that side of the square. So each of those are going to be 3s. So I'm going to start by finding L, my slant height, first, using this triangle right there. So we could use that right triangle in the Pythagorean theorem. 3 squared plus L squared must equal 5 squared. I kind of hope you guys have this memorized by now, that L is going to come out as 4. Okay, so let's fill that in. Okay, so now I know that is 4. Then what I want you guys to use is I see another right triangle that I'm going to use to find H. Okay, the height is always perpendicular to the base. So this time I'm going to focus in on this triangle. Okay, what I need to realize is I was told if it's a regular pyramid that that is the center. Okay, so it would be 6 units all the way across my square, meaning that that piece there from here to here is 3. So I have a 3, H, and the hypotenuse is 4. So let's figure out what H would have to be. 3 squared plus H squared must equal 4 squared. So 9 plus h squared must equal 16. H squared must equal 7 by subtracting my 9. So h is radical 7. Okay, and that's perfectly fine. We can have radicals in our answer. We can't expect things to always work out as nice whole numbers. Okay, next let's find our lateral area. Okay, we have a formula that told us it is 1/2 the perimeter times the slant height. So that's 1/2, since this is a square, 6 times 4, I know my perimeter is 24, and we found our slant height was 4. Go ahead and multiply that out. That comes out as 48. Okay, now to find our total area, we want to do our lateral area plus just the one base that it has. That capital B is base area again. So lateral area was 48 plus the base is a square with side length 6, so it's going to have area 36. Go ahead and add those together to get your total area, and it comes out as 84. Okay, we only have the volume left to find. Okay, our formula, our theorem told us it is 1/3 the base area times h, the actual height of the pyramid. So 1/3, we just found our base area, it's 36, and our height is rad 7. Okay, so just simplify this. 1/3 of 36 is 12. So 12 rad 7 would be our volume.